for printing multicolor what do you call it? Cartons, cardboard cartons and cardboard papers. So for them, we need to have compressed air that is actually for feeding the papers into the machine. So usually they use suction cups to separate sheets from a stack of papers, and the papers are fed into the machines before the printing process commences. Printing process commences. So that's one example, and also where we have some printing rollers to be engaged using pneumatic cylinders. So to operate those pneumatic cylinders, you require compressed air. So usually in a production flow, the compressed air is usually supplied to various parts of the building with a network of pipes. Okay? Usually GI pipes. So a similar system is shown in this image. So here we have the compressor, air compressor, and after that we have a valve or valve for disconnection whenever it's necessary. After that, there is a air dryer unit, a refrigerated air dryer unit. Refrigeration is done actually once you do the compression of air. Uh, because of the moisture content of air, there's a presence of moisture content in the air. When you compress air, it gets what do you call condensed. Usually we use the dryer, refrigerated air dry unit actually to separate the moisture out of that. So since the compressed air, when it is passing through the refrigeration dry unit, the water gets condensed, and the moisture can be removed out of this. What you get out of this one is the dry air, relatively dry air, because you can't completely remove the uh, moisture content. So there will be some remaining moisture again going into the receiver. Receiver is the tank, the air tank where we keep the air at a higher pressure. Usually 6 plus ATM pressure, 6 plus bar pressure is maintained, more than 6 usually. And after that, from the receiver, there's a network of pipes, uh, usually to distribute air to various points where it's necessary in the manufacturing flow to all the points where the machines are there. So you can route these piping to those points where there is a usage. Okay? And at the machine level, at the machine, what do you call the location, when you are wanting to use compressed air, what happens is usually uh, there is a ball valve and a quick coupling. Quick coupling uh, at the point of use, quick coupling is something like this. A quick coupling is used to easily fix and engage and disengage the piping, the compressed air piping. Usually at that point, there is a FRL unit. FRL means filter regulating unit. Here also there is the filter unit. Here this is a filter, and we have a pressure regulator here. That means usually a line pressure is about 6 bar. So you can with this regulator you can reduce the pressure to the required level. For certain use cases, we will require less pressure. Therefore, you have to adjust the regulate accordingly to get the desired pressure. And there's a lubricator also here. Uh, so that will supply some lubricants into the compressed air. And here, in the filter, the any remaining moisture will be contained in this filter, and there is a drain valve down here. So with the drain valve, you can drain the water that is getting collected here uh, from time to time. Okay? So if you consider any piece of equipment that you are going to use, in this case, you see an air tool that is operated with compressed air. So you have to connect the air hose to the equipment, and also the other side of the air hose is connected to the male part of the male part of the quick coupling, and that is fixed to the quick coupling here. Okay. After that, you can operate this one, the R2. So similarly, any other equipment you can fix. So at any point where there is a machine used to you know, uh, to be operated or using compressed air, we need to have a FRL unit like that. It's a good practice to have that, but usually in maintenance organizations, in organizations where they do operations like that, sometimes they do not use this piece of equipment, but that's not a good practice. If it's a good practice, the use of this filter regulator unit is a must because it has advantages. So here it is another setup. So we have a compressors. Actually, this box type compressor is uh, what do you call a screw type compressor. Screw type compressor. Yeah, but with the screw type compressor, we can pressurize air to a higher pressure. Okay. So that's what this reason why we use air compressors like these in industrial applications where you have higher air consumption. Okay, so we have a vertical type air receiver tank, and these are some filters, the air filters, and we have a dryer here, a dryer, refrigerated dryer that condenses the moisture and is removed from the compressed air line. And these are the two types of compressors used. Here we have a centrifugal type compressor. So here you can see, if you see the figure, under this one. So we have a compressor unit with the two pistons, a V type uh, a compressor with two pistons. So actually, this is a two-stage compressor. So here, within this cylinder, compression happens. After that, the air will be supplied to this one. Uh, so after that, the compression again it will be compressed. Compressed air will again be compressed using that cylinder, and after that, the compressed air after the second stage compression, the air will be directed into the tank. Okay. So that's because with just one cylinder you can't get enough compression. So therefore you use two-stage compression. So sometimes you would have seen, when considering this, the small pipe connecting these two cylinders, there are some cooling fins fitted uh, onto the tube here. This is usually a metal, a tube to which metal fins are fitted to that, because once you compress air in one cylinder, usually the temperature of air increases. So after that, when it is the air is supplied from the first cylinder to the second cylinder, uh, within this path, if you have cooling fins, that heat can be dissipated. Heat can be dissipated, and you can cool compressed air. So that's what we usually call, I mean, the intercooling. Intercooling means cooling air between those two stages of compression. So you would have heard of this. Um, uh, I mean, when you are referring to the old Montero jeeps, you would have seen the written line on the body of the vehicle. Peugeot intercooler. The intercooler means that so you use uh, the uh, the cooling between two-stage compression of the turbocharger. Um, and so the other type is called um, the screw type air compressor. So this one is a screw type air compressor. So this is how it looks. So here we have two screws that are running. I mean, that are in mesh, and they are running in mesh. So from the input, we input AI into this one, and with the operation of the screws, you can compress air, and the compressed air will be sent out to the receiver tank. So here, as you can see, there is a complex operation is going on here. So here, usually there should be some lubrication necessary. So therefore, uh, there's a oil pump also, oil pump, and there's an oil separator circuit as well inside. Because when you are taking out compressed air, that should not contain oil. So even though you use oil for the operation, oil will be separated before the discharge of compressed air out of the compressor. So therefore, there is a oil separator, what do you call it, we separate circuit to run oil inside the compression circuit. So here we have a filter unit to filter out oil. In the case of any contaminants in the oil, it will be filtered by the filters. And so due to the high the compression ratio, we use this screw type of compressors in industrial application. And these are some of the components, actuators operated by compressed air lines. So this is a pneumatic actuator. As you can see, so there are some other components also, like pneumatic motors and rodless cylinders, single acting, double acting cylinders, and also here we have there are some pumps also. Previously I showed you a diaphragm pump. So those kind of diaphragm pumps are also operated with compressed air. And then here there is a valve, pneumatically operated valve. It's a gate valve, so you can open and close the water supply valve with the compressed air supply. So like that, there are such pneumatic actuators and the devices operated by compressed air supply. So to operate those things in industrial applications, we have to use compressed air. So here this is just a list of pneumatic fittings and also some of the pneumatic components used in pneumatic circuits. So here we can see the flow regulators, so you can regulate the airflow to various machinery and equipment, and we have solenoid valves to direct compressed air supply to various sections, or maybe we can operate pneumatic cylinders or motors with this kind of valves, and we have a pressure regulator. So you should know the flow regulator and pressure regulator. So here we don't reduce the pressure. We just reduce the the flow rate of the air supply. And with this one, you can reduce the supply pressure. Okay? So I mean, this is what we call a header. So in case you need to supply compressed air to three separate devices, then we have to use this fitting. And we have another FRA unit like that. There are different kind of fittings used in various types of applications. So there is a manually operated switch here to connect and disconnect pneumatic circuit. So like that, and this is also a manually operated solenoid valve. Okay. Other than this one, we can find many other components also. I have just listed only few of these available, the commonly used pneumatic components used in compressed air systems. So I think you will be learning about these things under electropneumatics. So therefore, it's not necessary to explain all these things in more detail. And so what you just need to understand is that there's a system of utility to supply compressed air for various machinery and equipment in a manufacturing or any other factory. Okay. And here there's some interesting point that I'm going to discuss here. That's actually the energy loss associated with compressed air leaks. Now, we discussed about various types of components. So, at any given time, you can see, due to certain defects of these, various pneumatic devices or components, so due to improper fixing of the tubing to these connectors, there can be air leakages. So if you happen to visit a factory in the morning hours before the operations start, you can clearly hear some hissing leakage of air from compressed air systems or machinery. So that's not a good sign. So you should try your best to identify air leakages and rectify those as early as possible, because the more air that leaks, the higher the energy consumption of the factory. So we can see here, I've just taken this example to highlight the importance of that. The identification of the air leaks in a factory. So here the hole size is 1 millimeter square. Let's say the uh, the pressure, the line pressure is 6 bar in a compressed air system. So in such cases, there is a loss of 5,800 rupees a year, but that is for a 1 millimeter square hole. So if you consider a large factory like this one that you see here in the image, there are many machinery running on compressed air, and so therefore there can be large number of holes, large number of leakages. So if you consider as a whole, the total the loss due to compressed air leaks will be immense. So therefore, you should try and fix those kind of compressed air leakages very importantly, because otherwise that can be a a major contributor to the electricity bill of your organization. Yeah, so that's about the compressed air system. So today we will have a uh, assignment, in class assignment. So you'll be getting 40 minutes to complete this. I have already created an assignment on LMS. Now the time is 4:30. So you can complete it by 5:10. Okay, you can complete the work by 5:10, and you have to upload your answer scripts to the LMS. Okay, so the other people like 26A and B, they have already done this one. So you can do it now and submit it to LMS. So within the lecture hour, you have to submit. You have to do the submission. So now you have 40 minutes starting from now. And also the assignment is already attached to the LMS also. From there also you can download it and refer. Hello, Amni. Oh, good evening.
දාලා දන්නේ ඒක බලන්න විදිහක් නැහැ මගේ LMS එකකින් මේ මොඩියුල් එක අයින් කරලා දාලා කවුද කියලා දන්නව නම් බා මම උට කතා කරලා කියනවනේ ඇයි අයින් කරේ කියලා මම කොහොමද දන්නේ ඒක චෙකින් ඈ ඔව් රෙකෝඩ් වෙන්න දැම්ම ඒක ආ බයි
You have 10 more minutes. You have 10 more minutes. The time is up. Can you please upload the answer scripts to LMS, please? Please upload the transcript. Please upload the answer scripts to the LMS. So in the meantime, I will continue the lecture.
Recording in progress.
So this is the next utility system available in most of the organizations and manufacturing facilities. This is usually the abbreviation HVAC is familiar to you, I guess. So that means heating, ventilation, and air conditioning. So mostly we consider air conditioning systems available and air conditioning equipment available in various organizations, manufacturing plants and commercial buildings. So this HVAC or HVAC systems usually do the regulation of indoor air quality and temperature and reach the relative humidity levels. Uh, so objective is to create a comfortable and safe working environment for the occupants and also to maintain optimal conditions for equipment and certain processes, uh, certain storage of goods and so on. Also we need conditioned space, and for an example, if you want to uh, do the storage of fruits and vegetable and also perishable items, for that you need a conditioned space. So for that we have to use a refrigerated space or air conditioned space. Refrigerated space means you have to, if you have to go to very low temperature levels, then we have to go for refrigerated system. So, but in the case of air conditioning, I usually we talk about the regulation of the temperature that is sufficient for the occupants and also for certain products like, let's say, pharmaceutical storage at certain temperatures, higher temperatures around 25 centigrade or so, and so on. So like that. So the air conditioning systems provide a conducive environment for the occupants as well as machinery, the processes and equipment. Okay? So therefore, this is considered as a utility, another essential utility in an organization. Here we will first take a look at various types of air conditioning systems used in industrial sector as well as in commercial buildings. So first of all, we will take a look at the basic vapor compression refrigeration cycle. So I hope most of you by now are aware what this is and how the basic vapor compression refrigeration cycle works. So any air conditioning system, I mean, most of the air conditioning systems are working on this the working principle of this vapor compression refrigeration cycle. So here the cycle consists of four main components, as you can see here. We have the compressor, condenser unit, expansion valve, and the evaporator unit. So the compressor you already know. If you consider the working fluid used in these the air conditioning or the refrigeration systems, is called refrigerant. So that refrigerant has a special property, and it usually it is a kind of uh, a liquid that has a lower boiling temperature. Okay. And if you look at the working of this refrigeration system, or the vapor compression refrigeration cycle, so with the compressor, you have the refrigerant vapor coming in from the input side into the compressor, and the compressor compresses it. And so output is going to be the vapor at a higher pressure. So that is again going into the condenser part. So basically, the temperature of the vapor is high. So therefore, this line is usually heated up, and it is now going into the condenser. This condenser consists of a coil, that has been provided with cooling fins all over the tubing. So that is to increase the area of the heat dissipation. So as a result, when you go to the end of the line, end of the coil, the temperature of the vapor reduces. So as a result, the paper gets condensed. Paper get condensed, and now it's going into the expansion valve. When it is going into the expansion valve, so this is basically a diffuser. What happens in the diffuser is that there's a sudden reduction of the pressure as well as the temperature. I mean, if you consider a diffuser, usually at the output there's a sudden pressure drop. It is expanded. So the expansion, the process is usually called expansion. After the expansion, the temperature drops. Temperature drops, and if you look at the properties of the products out of the expansion well, this is a mixture of liquid and vapor. When the mixture of liquid and vapor is going into this the evaporator, so this is the evaporator head that is usually inside the indoor unit of an air conditioner. So if you know, since you have some understanding about household air conditioning unit, usually split, those are called split type air conditioning unit. So inside the indoor unit, you have this evaporator part, and there also we have a similar component like condenser, but here the this there's a coil, a copper coil here. And similarly, similar to the condenser, you have some cooling fins, connected to it, and so as a result, due to the low the temperature of the liquid and vapor, refrigerant, the this fan will blow air over this evaporated unit. So as a result, now here inside the room, we have warm air. When you are blowing warm air on this one, that heat will be absorbed by the refrigerant. When heat is absorbed by the refrigerant, this liquid and vapor will absorb the heat, and it will be converted into vapor. So the temperature will increase. After that, that vapor containing the absorbed heat will be again fed into the compressor unit. So like that, this is a cyclical process that happens. So cyclically this process will happen, and so as a result, we will get a cooler air, ambient temperature inside the cabin. Okay. So this is the basic principle of vapor compression refrigeration cycle. Now we will take a look at various types of air conditioning equipment usually used in practice. So the most common type of air conditioning system available nowadays is called split type air conditioning unit. So usually in households and smaller buildings and commercial establishments, and even in factory level. I mean, even in factories, you can find these kind of split air conditioning units. There are many applications of this common type of split type of air conditioning unit. So these usually consist of two parts. Usually we call them indoor unit and outdoor unit. Indoor unit houses the evaporator that I explained previously, and also outdoor unit houses the condenser. So these two units and other components like the expansion valve and also the compressor unit, those are interconnected using copper tubes. So those are called the piping. The uh, refrigerant is used as a working fluid running inside the piping. Okay. This is for usually used for smaller areas to cool smaller spaces, and I will show you an image of that in the second slide. And the second type is called packaged air conditioners. Packaged units, usually this package unit consists of all these components within one single unit. That's called evaporator, condenser, compressor, and expansion valve. All are inside one unit. And if you have been to this, uh, we have been to any of those, what do you call it, supermarkets like Cargill's Food City, usually those kind of packaged air conditioning systems are used in those, what do you call it, the shopping malls. Shopping malls means the market, supermarkets. So in supermarkets, this packaged type of air conditioners are popular. And sometimes you have packaged air conditioning units also connected to ducts. Duct means steel ducting that are being connected to this packaged air conditioning unit, and there are some diffusers on the ducts, and they supply air into the building. So I will show you one image of the same later, then we will get a better understanding. And this kind of packaged air conditioners are used in commercial buildings, usually like those supermarkets and I mean in certain hospitals and maybe in buildings inside universities, like especially since they are of relatively higher capacities, they can be used to condition air inside some relatively large spaces. So here this image shows you the basic components of split type of air conditioning unit. So this is what we call the outdoor unit. So we have a fan over here to blow air over the condenser unit. So if you have been to, if you have gone close to one of these, you can feel that the hot air that is coming out of this. So that's because the heat is rejected into the environment through this the condenser, that is refrigerant that has absorbed heat from the building inside is rejected out of this one into the environment in the outdoor unit. Okay? And the next image shows you the evaporator, or the next image shows you the package type air conditioning unit. But here I have shown package type air conditioning unit with water cooling. So they also have uh, package type air conditioning systems with air cooling also. And here, if you can see the evaporator, expansion valve, condenser, compressor, all housed in one single system. Usually, this is kept inside the building, and only the refrigerant lines are coming out of this. Sorry. So not the refrigerant lines, the water lines. The water lines will be coming from this. Usually this condenser is a shell and tube type heat exchanger. Heat exchanger means now you have coils inside, coils in which you have refrigerant that is being circulated, and that is actually dipped inside the water. So this water is also what do you call circulated by using a pump. So here we have a water pump. With that water pump, you can circulate water into the condenser unit and out of the condenser unit. And once the water goes inside the condenser, the heat from those the coils, heat from the coils will be rejected into water that is present in the condenser. That water is again going into this cooling tower. So I will explain the function of the cooling tower later. So here in the cooling tower, what happens is this hot water will be converted into cold, relatively low temperature water due to the heat rejection. So usually what happens is now we have a fan, a blower here. What a blower does is usually when the blower is operating, airflow is from the bottom to top. So usually there is a mesh surrounding this cooling tower. So through these meshes, the air will be coming in and it will be forced out of this. So as a result, now when the condensed water is dripping through this, not dripping actually, it's sprayed out of these. There are a few nozzles here. Through the nozzles, the water will be sprayed out. So when the water drips here, against the flow of water, there is a flow of air. So as a result, there will be a cooling action. So as a result, the heat the water will be rejected into the environment, into the atmosphere. And here is there is the basin here. So all the water will get collected to the basin. After that, same water will be circulated through the pump into the condenser again. So this is happening in cyclical manner. I mean, the heat rejection is happening here at the cooling tower. So you can use same water, the same water all over again for the cooling of condenser. So as a result, so there is a heat rejection, and also in the form of water vapor also there is a drop of the water volume. So here usually there is a pipe that is connected to a ball valve. If the water level reduces to a certain level, the water will be supplied into this. So due to the evaporation of water in the form of vapor, there is a reduction of the water quantity, water quantity. So the additional water will be pumped into that using the ball valve mechanism. So that's the main function of this package type air conditioning unit. And also we have a central air conditioning system. So that's a different type of system. Usually central air conditioning systems are huge. They are very large, and you can supply cold, you can air condition in a very large area. Usually, if you consider high-rise buildings and large shopping malls and large factory floors, so those areas are the areas where these central air conditioning systems are used. Usually, we have chillers, a kind of air conditioning system called chiller, chiller unit, and we will talk about that separately because that's an important type of an air conditioning system. So we will discuss more on that later on. And also we have ductless mini split type of systems. So this is quite similar to normal split type air conditioning unit, but the difference is so as this you can see the image here. So here we have two indoor units connected to the same outdoor unit. So like that, there are split type of what we call the mini split systems that can support more than two uh, indoor units also. So here you can see there are two fans here, two fan blades units here. So like that, uh, you can use the same system to air conditioning into separate areas with this kind of mini split system. So this is just an image of a water uh, central air conditioning system based on water chiller. So that we will discuss later on, because here what you do is you just reduce the temperature of water. So you have water that is being used as a working fluid that transfers the chilled water to various parts of the building. So that actually provides a cooling effect into the areas of the building. So we will discuss further later on. And we also have another type called variable refrigerant flow systems. This is something relatively new kind of a technology. This is called variable refrigerant flow and commonly known as VRF. Yeah, VRF, and there are two names interchangeably used these two terms, VRF and VRB. VRF stands for variable refrigerant flow, and VRB stands for variable refrigeration volume. So I will tell you how those two terms have been coined. Um, so this one again on chilled water systems involving the chiller unit, cooling tower, the pumps and air handling units. That will be the components of chilled water system that is supplying cool air into large commercial buildings and factory buildings. So those things we will discuss later. And so this VRF or VRB term was introduced by this company called Daikin. So they are the ones first introduced this concept of variable refrigerant volume. So they manufactured this variable refrigerant volume air type of air conditioners. So here what happens is you have the air conditioning system and you change the flow of refrigerant flowing through the cycle, flowing through the cycle, so that the speed of the flow will vary according to the demand of demand or the load of the cooling load. Okay? So the higher the cooling load, the higher the flow of refrigerant will be. So that will be looked after by the pumps. So all type of compressor that is inside the outdoor unit of these VRV system. So the RPM of that compressor can be changed using the inverter technology, and so as a result, we have a lot of benefits out of this. So we will discuss about that later. So just to show you the types of the components of key components of this VRV system. And you have the outdoor unit, that's a condensing unit, and also we have multiple number of indoor units. Similarly, similar to that, the last one that I showed you. But here you have, number of fan coil units or the indoor units can be used, and the temperature level of temperature set points of those individual the fan coil units can be changed according to your wish. If there are separated areas, partitioned areas, so those partitioned areas can be air conditioned, and the parameters like temperature can be varied to whatever the level that you need, okay? Irrespective of what the other units are operating at. So you can individually change the temperature level inside those specific areas. And also, one thing I forgot was that the term VRF. So I told you that Daikin, they invented this technology, variable pressure and volume, and so the same technology was later used by other companies, other air conditioning manufacturers also used. So they used a different term called VRF, variable refrigerant flow. So that's how these two terms came into being, and basically the technologies are not different, but they are based on um, the manufacturer of these air conditioning equipment, as you can see. Okay. So let's take a look at this diagram. Here we have the outdoor unit, and you can see there are multiple number of indoor units here, and you have liquid piping running, and also we have large number of indoor units, and other than that, you can leave some room for further expansions or the future expansions also. That's the important thing in this one. So usually in the design phase, you have to decide that. Let's say presently you have requirement for 8 indoor units, and you will need 6 more units to be added later on. So you size the outdoor unit accordingly. So you have to do that at the beginning before the selection of the conditioning system. After that, you can keep these what do you call closed, and later on you can add any other indoor unit necessary, depending on when you are going to expand the area for the refrigeration system, area for the air conditioning. Okay, so that's important thing, and since now let's say we are running this few of these units, so accordingly the refrigerant flow will change accordingly. And if you are, let's say you are not operating one of these units, then the refrigerant flow will be bypassed. It will be bypassed, and it will be going to the next unit that is operating. And as a result, the compressor, there's a compressor. Usually there are two compressors. One compressor is running when you are starting the machine. When you are starting it, it is the one that is going to start after some time. Let's say after turning on these air conditioners, when they come to the necessary temperature levels. So the next unit, the one with the inverter function will take over. So that will turn on different RPM values. I mean that RPM of that unit can be changed depending on the requirement of the cooling load. Okay. So that's why usually the energy efficiency of this VRF or VRV systems is very much better than any other conventional type of air conditioning systems. And we have refrigerant lines and branch selector boxes here, and we have refrigerant lines indicated by this red color and blue color, and so this is the controlling manifold, and here we have the selector boxes, we call branch selector boxes. So you control these branch selector boxes to control the amount of the liquid flow that is going to flow to these indoor units depending on the cooling requirement. And and if you look at the basic features of the VRV type of systems, so here, as we discussed, the refrigerant flow will have variable flow rates. So depending on the RPM of the compressor, the refrigerant flow will vary. So that actually varies depending on the cooling load. The higher the cooling load, you will have a higher flow rate. If you have less loads, then the flow rate will be slower. That is where you are equipped to supply to those rooms, supply air conditioning to those few areas. And also another impressive advantage is that you can use the VRV systems for simultaneous heating and cooling. Now, you know that in our case, in our country, we use our air conditioning systems only for cooling, but in other colder countries, they use what is called heat pumps. Heat pump is actually the reverse of air conditioning system. Now, we understand that the evaporator unit rejects heat into the atmosphere. So in our case, our country, the climate is a tropical climate and it's very warm out there. So therefore, we need to reduce the temperature of the space that you are living in, living spaces. So therefore, we have the evaporator unit usually inside the room. So in the case of colder countries, you need the reverse of it. That is the condenser unit is usually placed inside. So we do not usually call it what do you call outdoor unit. So there are specifically designed heat pumps for those applications, for heating applications. So these kind of equipment that we use in our households or in buildings in Sri Lanka, we can't use them directly in colder countries because the heat pumps are of a different design. So there are already built heat pumps for that purpose. And coming back to simultaneous heating and cooling, now in the case of VRVs, you can heat one area while cooling is happening in other areas inside the building. So that's a very important thing because usually when you are cooling a certain space, that is, you are trying to reduce the temperature, you are absorbing heat in that space. Okay? So that absorbed heat will be rejected into the space where you need heating. So that's the inclusive nature of this VRV system. So therefore, uh, I mean, you don't have to spend energy on that. Yeah. So that's one reason why the VRV systems have a higher energy efficiency. Zoning and individual control is now for various zones, we can have different temperature levels. There is in the same area, if you have partition spaces, various spaces, so at each of those spaces, we can have different temperature settings, and you can control them individually. Okay. And energy efficiency comes from this the inverter driven compressors and also by adjusting the refrigerant flow. So as a result, the energy is optimized under these VRV systems. The heat recovery is what I have explained previously. There is heat rejected from where we need to cool will be used or utilized in areas where we need to heat. So that's actually the heat recovery. Use unnecessary heat from one particular area, and it will be utilized in an area where you need to do heating. So that's one advantage also. And usually these VRV systems come with advanced controls, and you can do centralized monitoring and scheduling of the operation of these VRV systems. That is, if you want to operate the air conditioning equipment during a certain period, starting from uh, sometime, and if the operation has to finish by a certain time, so those scheduling work you can do with those advanced control software applications. that are used for those applications. And also remotely also we can operate certain VRA systems have remote control capabilities. So separately, you can control the temperature set points and so on. And you can do the monitoring function also. And yeah, it's kind of like a mini SCADA built into the VRA system. And listing of the advantages, talking about the advantages of VR-based systems. So I've listed 5 of the advantages, most of which we have already discussed: energy efficiency, individual comfort control, simultaneous meeting and phoning, sounding, flexibility, flexible installation, flexible. So these 4 things we have already discussed. So flexible installation means now, depending on the building type, and let's say if you are wanting to add more units later on, so then you can install it and leave the other connections closed, so you can add new units later on. And also, if you consider water pools or the air pool type VR systems, the outdoor units are relatively smaller in size, so therefore you don't need larger space to keep those. So especially if you consider chiller systems, like then you need to have a larger space to keep those cooling towers and other accessories, condenser water pumps, chill water pumps. So yeah, the space required is very large in those cases. But in the case of VR system, you don't need that much of space comparatively. And so here there's a small video. So I'm not going to play it here now. So I will share this with you. And you can maybe, I don't know, I've already shared it with the other group, 26A and B groups. So if you haven't got it, then I will share it again. So it's better to take a look at this video that explains how it works, and also give you an introduction into basic vapor compression refrigeration cycles. Okay. And
We all know
so now we will now take a look at the basics of chilled water air conditioning system, which I told that I will be discussing in more detail. So it is the vapor compression refrigeration cycle that is used here also. The only difference is that the configuration is different, but here now you can see um, the condenser coil and evaporator coil, they are inside these 2 heat exchangers. So here we have the evaporator heat exchanger. Here we have the condenser heat exchanger. So in this heat exchanger, inside you have large evaporator coil. Now you can see after um, the yeah, sorry. After the expansion well, you have the refrigerant that is at a lower temperature. It will be going into the evaporator. So evaporator, in the evaporator, the heat from the water will be absorbed by the coil, and the refrigerant will be going into the compressor. Okay, so after that compression happens, and the temperature will increase, and the heated refrigerant will be going into this the condenser coil. That condenser coil is surrounded by water in this heat exchanger. Here, this evaporator coil is surrounded by water, and as a result, the water we take water. Now we just normal water we are taking from the process, that is from the cooling process. The water is coming into this the evaporator heat exchanger, and and so that is being cooled by the cooling coil inside. And after that, once it is cooled, usually it is cooled to a temperature around 6-7 degrees Celsius, and it is going again into the process. There is process means you are supplying this cooled water into air conditioning units. So the return water from those air conditioning unit comes line indicated by the red color, and it is again cooled using the cooling coil, and again the temperature drops to 6 or 7, and it's going again into the process. So that's what happens in the operator. In the condenser unit, in the meantime, so you are getting the warm refrigerant into this, and it is circulated inside the coil, and the coil is surrounded by water. So water absorbs the heat from the refrigerant, and heated water will be going into the yeah, into the what do you call this, the cooling towers. The heated water is going into the cooling tower. And I told you when I was explaining about the package type air conditioning units, the after the heat rejection at the cooling tower, the water, cold water will be dripping onto the basin at the bottom. So from that basin, water is returning into uh, the water, what do you call this, the heat exchanger unit. Okay, so that is also happening in circulation, and there is condensed water heat absorption and heat rejection will also happen within this cycle here. Um, here water cooling, and also the water cooling also will happen, and heat rejection also will happen, heat absorption also will happen within this process. Okay, so that's the main difference between a regular air conditioning system and a chiller system like this. So this one, this animation shows you how this chiller works, and there are two types depending on the type of cooling of the condenser. So here we have a air cooled condenser, and here we have a water cooled condenser. Only the water cooled condenser will use the cooling tower for heat rejection purposes. But here we use fresh air blown over the condenser to cool the coil or the condenser coil. Okay. So if you move to the next slide, then you can see. So this is the condenser unit of an air cooled unit, air cooled chiller unit. So here we have a condenser coils. So yeah, on top of this we have a large number of fans running at higher RPMs, blowing air through this, and by reducing the temperature of the refrigerant running inside. So here this is a water cooled type of a chiller unit. So this one and this one, these are the two heat exchangers. So one is a evaporator heat exchanger, the other one is a condenser heat exchanger. So you have two large pipes like here. So one is the input, the other one is the output. So on the other side of this, what do you call the container, also you have two pipes like that. So one is connecting to the cooling tower, sorry, to the condenser pumps. The other one is connected to the air conditioning equipment. Okay. Yeah. So let's see what are the components of a chiller unit. So from then and there, I discussed about certain components, but here we will list the main components, the key components of the chiller unit. So you have the compressor, evaporator, condenser, and expansion valve. So basically these things are used as in the case of any other type of air conditioning system also. So here also this is a diagram that clearly shows you how the condenser and the evaporator works, and this cutaway diagram shows you how the tubes are running inside this the heat exchanger unit, and tubes that are running inside the evaporator unit. So it's the refrigerant that is running this, and it's surrounded by water. Okay. And other components are also the expansion well, and so the important here is that now the refrigerant is running only in this within these units. Refrigerant is running within these units, even though you have to transport cold water to various parts of the building, covering a large distance. So you can easily identify whether there is a leak of water or not. But in the case of any leak of the refrigerant, then we'll have to trace that leak and try to fix it. No, but in this case, therefore, in terms of maintenance, it is much easier because it's the cooling medium is water, the cool water, and water is transported to the locations required, and using fan coil units, you can condition that space. Usually, when water is flowing through the unit called fan coil unit, through the coil, the air is blown. So the air will be air will have less temperature when it is coming out of the coil. So that's how the temperature of the area or intended area is reduced. And if you talk about the refrigerant is the working fluid of this um, air conditioning equipment. So we have various types of refrigerants used. So R134E, R410A, R22. So these are actually not no longer used. R22 are very rarely used nowadays. R134A, if you have seen vehicle air conditioning system, so this R134A is used, but now these are replaced with new types of air conditioning refrigerants. So they are more eco-friendly. So these are not kind of CFC free. These actually harm. These can harm ozone layer of the atmosphere. So therefore, the production of these refrigerant types are limited nowadays. So they are being phased out with newer types of refrigerants, newer and environmentally friendly refrigerants. And chilled water systems require chilled water circuit and chilled water pump. So this chilled water pump is used. I told you that once water is chilled by circulating water inside that heat exchanger, it should be pumped to transport into large area. So for that we use chilled water pumps, large pumps. A set of pumps are used. Usually there is one pump in a usual setup. There's one running pump. There's a standby pump. So when one unit is one pump is running within 1 week, then it will be the next one will be operated in the coming week. Alternately, these two units will be operating. So that's how usually systems are designed. Therefore, usually you can see uh, chilled water pumps. There are two chilled water pumps being used mostly. I mean, at least two pumps you use in a air conditioning or the air chiller system. So this is the indoor unit or you have the heat exchanger in one unit. You can see the other one is on the other side, and this is what we call the chiller unit. And so here we have the condenser pumps. Here in this case, there are three condenser pumps in the picture. So like that, if you have multiple number of pumps, that's much better because you can improve the reliability of the system. So this is what we call the cooling tower. So using the chill, not the chill, this is not a chill water pump, this is actually condenser water pump. So condenser water pumps will supply the hot water coming from the heat exchanger into those cooling towers. So they are actually supplied at the top of this. Okay? When the water drips, the cold water will get collected at the bottom basin and again it will be recirculated within the system. So now let's take a look at this cooling tower, the function I just explained about that. So if you look at the schematic of the cooling tower, it will be like that. So here you can see there's a mesh here. So this is the mesh through which the pressure will be coming into this. So here we have a blower fan. So blower fan is extracting the air out of this. Basically, the path of the airflow is like that. So dry air is coming in and going to the top and getting out of the cooling tower at the top. Okay? And as a result, you can see the flow of air and the flow of the water that is being sprinkled at the top are opposite to each other, opposite to each other, or opposite to each other. So as a result, the heat from the water will be rejected into this, and also there is a filler material here. When the water contacts the fill material, the surface area of the water also will increase. So this is kind of a mesh-like, and there are some openings in the filler material, and when this is soaked with water, so there is a ample amount of surface area to reject heat. Okay? After that, the water will drip onto the collection basin at the bottom, and the water will be again recirculated through the condenser unit. Okay. So that's the usual method of operation of the cooling tower. So we will stop for the time being, and we will continue from the next class. So I see that there are more people than who did this assignment. When you were doing assignments, there are only 10 people. There are two people who joined later on. So I would like to request those two people to vacate immediately because I don't want them to sign the what do you call it? I don't want them to scan the QR code to mark attendance. So uh, if you are having the integrity, then please vacate immediately. Those who have been there right throughout can only mark the attendance. So let me share the attendance sheet. So I will stop sharing this demo. Yes, those who have been throughout the lecture, please mark the attendance. I don't want any others to mark the attendance because it's not fair. It's not fair by those who have been there right throughout 2 hours. So please mark the attendance. And also you will be having the mid examination. Not in the coming week. I think you won't be having any lectures in the coming week. So week after next week, you will be having this what you call mid semester exam. So that will be a closed book one. So everybody will have to come on maybe on Saturday to sit for the examination. I don't know whether you have any problems with that. So please let me know any convenient date. Then we will have it. So anyway, the other group, 26 A and B groups, will be having it in the week after next. Yeah, it's going to be a physical exam. So you'll be having a physical exam. Because there's no point in doing a what do you call online exam, because obviously you are going to reproduce contents of AI tools, so that's totally pointless. Yes, there is no point in assessing also. So therefore, it's essential that you use it for a physical closed book examination rather than facing open book one. Please let me know when you're finished with this, then we will wind up the program, wind up the lecture. If you have mounted your attendance, you can leave.